Hello and welcome to lecture number 3. Lecture number 3 deals with file output. So we've seen file input in lecture 2. So go ahead and open up your program editor. And I've got 11 steps here. We're going to create an instance of ofstream for input file, create an instance of ofstream, the output file. We're going to set up an array of floats so that we can read data from the input file and store it into the array, do some transformation on it, and then send it back out to the output file. We'll open table data using ofstream. We'll create a new table data file using ofstream. We'll read those floats. I guess I covered that. We'll print the array to the console to prove that we read it in. We will square the floating point numbers that are stored in the array, meaning multiply them by themselves, and then we'll write out that array to the new table data file and then close the two files. At that point, we'll jump out to the operating system to see what it looks like. So follow along. That's very important that you actually create these files and that you actually compile them and execute them for yourself. So I won't repeat things that we are starting to learn. So I'll just quickly put some comments in here. Now I need to include fstream because that's where we get the ifstream and ofstream objects from, or variables from. Okay, using namespace standard int main. Okay, so let's go to the comment where step number 1 is create an instance of ifstream. ifstream is our variable type. I'll call it variable for now, and we'll name the variable table. ofstream is going to be for our output file, and we'll call that new table. And then we'll set up an array of floats, 10 floats, and we access those by a subscript 0, a subscript 1, dot dot dot, all the way through a subscript 9. Okay, now let's go ahead and open table data. So we use table.open and then we pass it the literal string name. Let's go ahead and check for table.fail to see if anything bad happened while we were trying to open the file. Whenever you ask the operating system to do file I/O, it's always good to check and verify that you had a successful operation. Okay, if we have a failure, we're going to process this if block, and I'll say error opening file table data. We could generalize this, but for now we'll just go ahead and we'll hard code it. And then we'll return to the operating system with an error code of 1. All right, now we'll open a new table, and that's called new table data. So that'll be the operating system name in the file system. And the same test, if table dot, oops, I'm sorry, I'm going a little too fast. If new table dot fail, actually I should do C error. Okay, error. Now make it look a little more like a professional message. Oops. That's, excuse me while I find my cursor. There we go. Okay, return. All right, So in both cases, table.open table data, test for a failure. If the failure is true, then we print a message to the standard error or the console error stream, and we say error opening file table data. For consistency, I'll go ahead and say could not open file table data. And then I'll come down here and make it consistent. Could not open file new table data. Okay, now we got some consistency there. But hard coding strings could also be done a different way. We could actually set up an array of error messages that we could index into to get the strings out so that we only ever have them show up one place, and then we just call them based on the error codes. And there's all kinds of things we can do. But for now, let's focus on reading in data and then writing it out. So now I want to loop. In fact, let me put a little comment here so that we don't lose track of what we're doing. Okay, read data into array. Okay. And then I'll say for int I equals 0, I less than 10, because again, we're just reading 10 lines of data that we wrote out in lecture 2. This is a little bit contrived because you usually don't read files with a for loop and a counter because you don't always know. In fact, you hardly ever know how many lines are in a file. But this is good enough for the time being because we want to focus on the mechanics of writing out a file, reading in a file. Okay, so I will say table and use the extraction operator and put it into a sub I. And so that's how we'll fill the array. And then I'll copy that. And I will change this to cout. And I'll change the extraction operator to an insertion operator, which is just flipping it over. And then I'll make it look pretty. I'll say a sub, and then I'll say I, and then I'll close the bracket, equals, and then we'll actually put the value there. And let's see, does that work? Yeah, that looks pretty good. And so that'll print out the array. So let me make another comment so we can keep track of what we're doing here. Otherwise it all starts to look the same. Okay. Next, I want to loop through the data in the array. And there's different ways to do this, but I'm just going to go ahead and use the same for loop construct for the time being. And I'm going to use a temp variable. I'm going to say float temp. And so that's inside of the for block, which starts here with the opening curly brace and ends here with the closing curly brace. And then I'm going to say that temp equals the value of the currently pointed to subscript. And when I say pointed to, we're indexed into it. So A0 is the first one. We're going to copy the value of A0 to temp. Then we're going to set the index that or the cell in the array that we just read from. We're now going to overwrite it by doing this. We're going to say temp times temp. And that's one way to square the number. Read what's there, put it in a temp variable, multiply it by itself, and store it back over what was there. And so you've basically clobbered the original number, and you now have the new number. You can get back to it, however, by dividing the number by itself. Actually, That didn't work. That would get you 1, wouldn't it? Dividing the number by 2. Oh, heck. You math people are going to make fun of me. All right. So now that loops all the way through and it squares the numbers. And so I'll put another comment up there just to show that. There we go. And for this, we'll say output array data to file. And then once again, I'm going to copy what I had up there. And note, I'm not using functions. I'm not taking time to do that right now because I just really want to focus on getting this file written. And so here we go. Basically, I'm going to loop through, and I'm going to loop through the array and send all of that out to new table. Now, I don't know if I went too fast. I wasn't all that careful. Do I have errors? I don't know. But we'll find out real soon when I start to compile. I'm going to put another comment in here so we can say what we're doing. All right. Square numbers in array. Okay. So I think I was right the first time. If I multiply something by itself, temp times temp, then to get back to the original number, I can divide AI by temp and get back to it. Okay. No more laughing at the teacher. Now I'll go out to the command window and I'll go try and compile this thing. So let me change to desktop, C++, Feb 16. All right, and here's my table data file from lecture 2, and here's my ofstream.cpp. That's the file that we just created together. So I don't know if it's going to compile, but we'll see. C++, I'll pass it the standard and ask it to please compile, conform it to C++ 11. I'll give it a nice output name, so it'll be ofstream.exe when I want to execute it, and then I need to tell it which source code to use, and that's the ofstream.cpp. Let's see what happens. Whoo, I didn't get an error. I got lucky. Okay, so I look and I see I have an ofstream.exe, and that was just written at 8:46 p.m. So now let's try. I don't know if it's going to work. Just because I compiled it without errors doesn't mean it's going to work. Just because I linked it without errors and created the executable doesn't mean it's going to work. I could have a logic error in the program. Something could blow up at runtime, and something did because I didn't see anything. I didn't see any output. I'm looking, I'm staring. I did create new table data, but it came out 0 bytes. So now I'm going to go debug my problem. I'm going to pause the video just so it's not too long, and then I'll come back once I figure it out. Okay, I'm back. That took me a couple of minutes, and then I took a phone call from my son. But other than that, we're back in business. So I started looking through my code, and I'm like, okay, gee, what could be wrong? I'm opening the input file. I'm opening the output file. No errors. I'm reading it in from the input file to the array. I then display the array, but nothing came out. I then square the number in the array. I then output. And then I realized, hey, wait a minute. I'm missing the end line character. I didn't force an end line. And so behind the scenes, the system is the cout class has a buffer, and it's buffering all the stuff, and I never forced it out to the screen. And then the second time here in my haste, I didn't include an end line after each line of data, and so it buffered that data, and it just never ever made it out to the disk. And so I think that's going to fix it. So let's give it a try again. I updated those two lines, and I came out here and I cleaned up a little bit. So you'll see after I compile that unless I have errors, I'm going to get my exe file. So here we go again. Okay, and let me do dir. Okay, there's my ofstream exe. Notice the size is a little different there. And now I have a table data input file. I'll go ahead and say type table data so we can verify that we have data, and we do. And now I'm going to actually run the program. And this time it outputs to the screen. That's this loop here. And you can see now I say a square bracket, and this I turns into 0 and then 1 all the way through 9 as I loop through here. And then here's the literal, I put the other bracket on there, that's where that comes from. The space, the equal sign, the space, right? And then I close that string off. And now I'm going to actually access the value in the array at index I, and that's where we get the numbers. So we read them from the file, we stuffed them in the array. I probably could have, I could have here print the array out a second time so you can see the numbers squared, but then I output the squared numbers to new table. And so the other way we can do it is just let's look at new table. So I'll say type new table data, and there we see the squares of the numbers. Anything that was negative is now positive, because negative times a negative is a positive. We see one here in scientific notation because it was really big. We can control that formatting using IO manip, and maybe I'll do that in a future lecture. But anyway, that proves that we were able to read the data in by opening a file, transforming the data in the array, and then writing out the transformed data to a new file. And that will end lecture 3.